this video, we're going to discuss finding probabilities for any normal distribution. Okay, so for example, say we have a normal distribution, looks like this. Okay, where its mean can be anything, you know, not necessarily 0, right? For the standard normal, it has to be 0, but this is any normal distribution. So say its mean is, I don't know, 4, and its standard deviation could be anything, say 2, you know, it doesn't need to be 0, 1. So this is some distribution of x, where x is any normally distributed random variable, not the standard normal distributions, standard normally distributed random variable, which we call z. Okay, so this is the distribution of x. So here in the center is 4. Okay, so how am I going to find, say, the probability that, x is less than 3? How am I going to find this? How am I going to find the probability that x is less than 3? Well, if it was z less than 3, there's no problem. I would just go to my table and I'd look it up, right? Well, the problem is now it's not z, it says x. So I'm going to have to use some sort of transformation to get to the distribution of z so that I'm able to use my table. Okay, so I need to figure out what is the corresponding value of z that corresponds to this 3 here. Okay, and then I can find this corresponding area. All right, so how am I going to do that? Well, there's this formula. Okay, z equals x minus mu divided by sigma. This formula will help me determine what is the value of this z that corresponds to this 3. Okay, all right, so actually, let's go ahead and do this. Let's go ahead and try to calculate this. So I'm going to transform this x into a z using this formula. So instead of it being 3 there, 3 is now the value of this little x. So 3 minus, now mu is 4, and sigma is 2. Okay, so this is the same thing as saying the probability that z is less than, well, 3 minus 4 is negative 1, divided by 2 is negative 0.5. All right, so this corresponding value of z, the value of z right there is negative 0.5. Okay, and then these two areas, the area that I see, here, and the area that is here are the same. All right, because I've used this transformation to make it so that this area and that area are the same. Okay, so probability that z is less than negative 0.5. Well, I can look that up in a table, sure. All right, so let's go to our table, look that up. Negative 0.5. Negative 0.5. So that is 0.3085. 0.3085. Right? So that makes sense, right? That we were expecting that number to be certainly less than half, right? So this is 0.3085. That makes sense. So that is the probability that x is less than 3. All right, let's do a few more examples. So we'll be using this transformation. This transformation is key for these sort of questions. All right, let's go on and do some more examples. Assume IQ scores are normally distributed with the mean of 100 and standard deviation of 15. IQ score is randomly selected from the population. Find the probability that the IQ score is less than 140. All right, so here we go. The mean of this distribution, so this is the distribution of IQ. So let's define x, distribution of x, where x is going to be the IQ score. Okay, and the mean of this distribution is 100. So mu equals 100, and sigma, standard deviation, is 15. Okay, I'm trying to find the probability that the randomly selected IQ score is less than 140. So here's 140, it's over to the right of 100. Okay, I'm trying to find the probability that's less than 140. So this area here, right? So the probability that x is less than 140. That's what I'm trying to figure out. All right, so to figure that out, I'm going to have to do the transformation to the distribution of z. All right, so here's 0. Here's some unknown z value. I'm going to have to figure out what that is. But these two areas, this area I'm marking here in purple and this area over here, should be the same, right, if I do that transformation correctly. Okay, so let me write down the transformation. I'll write it down over here. So the transformation is z. So this is, well, I should mark this distribution of z. Okay, so the transformation is z equals x minus mu divided by sigma. So transformation from x to z. And what I'm transforming is this number here, this 140. I'm looking for the corresponding value of the z here. So 140 minus mu, mu is 100, divided by 15. All right, might need a calculator for that. So let's go ahead and calculate that. 140 minus 100 is 40. And then divide that by 15. So we get 2.6. Well, okay, when we go to our table, remember the z table only has 2 decimal places for the z value. So all z, when I do this transformation, I should always round to 2 decimal places. It's very important that you remember that, okay? Always round to 2 decimal places. So I'm going to take 2.67. All right. So this is going to equal the probability that z is less than 2.67. Okay, what we did was we rounded the 6666 to 0.67. All right, so this value of z that cuts right there is 2.67. So let me go and erase that circle and let me mark that as 2.67. So these areas now should be the same. Okay, so let me go in my table and let's look up 2.67. So 2.6 all the way over to 7, 2.67, so that's 0.9962. All right. So there we go, there's my answer, 0.9962. That's the probability that the randomly selected z-score will be less than 140. So it's very likely that it will be less than 140. All right, let's find the probability that the IQ score is more than 115. All right, so again, I'm going to start with the distribution of x. Okay, so here is, in the center was 100. We're talking about 115, which is still to the right of 100. But we're talking about more than 115, so that'd be this area to the right. Okay, so I'm trying to figure out what's the probability that x is more than 115. All right, so the first thing I'm going to do is I'm still going to transform to the distribution of z. I want to find what this value here is. What is this value such that these areas are going to be the same? Okay, so to do that, I'm going to use my transformation. So z equals x minus mu divided by sigma. All right, so, oh, let me erase that. It doesn't make sense to write that without the probability. So probability that z, so change the x to a z, is more than, so I'm trying to change over, is this 115. So 115 minus mu, which is 100, divided by the standard deviation, which was 15. Okay, so this is equal to the probability that z is greater than 1, right? 15 divided by 15 is 1. All right, so this number here is 1. So I'm trying to find the probability that z is more than 1. Right? Then these areas will be the same for both distributions. Okay, so how do I figure that out? Well, actually, if I go straight to my table and I look up 1, it's not going to tell me that area in front of 1. It's going to tell me the area behind 1, right? So whatever value I look up, when I look up and I find that area, I should do 1 minus what I find in the table, right? Because the table will give me the area behind 1, right? Remember, tables provide the probability that z is less than 1. So I'll have to take 1 minus the value in the table. So let's go to the table. Let's look up 1. 0.8413. Okay, then do 1 minus it. Go ahead and pull out your calculator. 1 minus 0.8413, 0.1587. All right, so it's pretty unlikely that you have a score that's randomly selected from this population who's more than 115. Actually, it's about 15.87% of the time you'll have a score that's randomly selected and it's more than 115. All right, last example. Find the probability that the IQ score will be between 110 and 120. Okay, so still starting with the distribution of x. Okay, so here in the center is 100. So I'm talking about between 110 and 120. All right, so here's 110. Here's 120. I'm talking about finding this area here. Okay, so I'm still going to do the first step the same. First thing I'm going to do is I'm going to try to transform this to the distribution of z. So I need to find two values now, though, because I need to know two cutoffs that I'm going to have this area. It's going to be the same as this area over here. Okay, so let's see. I'm going to go ahead and write this out. So I'm trying to find the probability that x is between 110 and 120. All right. So transformation again is z equals x minus mu divided by sigma. So first, let's start with the 110. Okay, so I'm transforming 110 right now to find this value here. Okay, so that's the value of x, 110, minus mu, which is 100, divided by sigma, which is 15. Okay, so now instead of x being in the center, it's going to be z. All right, now I'm trying to find this value here. Okay, so this is the distribution of z. Okay, so I'm trying to find this value here. So that would be the corresponding mark for 120. So x is 120 minus mu, 100, divided by sigma, which is 15. All right, so this is going to, let's go ahead and calculate these guys. So this will be, oops, let me pull up the calculator. So that will be 10 divided by 15, which is 0.66666. So don't forget, you need to round to 2 decimal places, so 0.67, right? And then the other one will be 20 divided by 15. 120 minus 100 is 20 divided by 15, which is 1.333. So you need to round to 2 decimal places, so that'll be 1.33. Okay, so 0.67, 1.33. Okay, so now we've talked about in the past how to find these sort of probabilities, right? Where z is in the middle, right? So to do this, you might want to draw it out again, right? So here we have 0.67, 1.33. Okay, if I look at my table for 1.33, it's going to tell me all of the area behind 1.33. So I'll look that up first, and then I'll subtract off the area that's behind 0.67. That'll tell me the area that's between the two, right? If I take all of this area, subtract off that area, be left with the area that's between. All right, so let me actually go ahead and write that as in terms of probability statements. So this will be equal to the probability that z is less than 1.33, right? That's looking up the 1.33 in the table, minus the probability that z is less than 0.67. That'll be when you look up 0.67 in the table. All right, so 1.33. Let's pull up the table. 1.33. 1.33. So that's 0.9082. Okay. 0.9082 minus 0.67, so we need to look up 0.67 in the table. The probability that z is less than 0.67. All right, the probability that z is less than 0.67 is 0.7486. All right. Okay, do that subtraction. Go ahead and pull out your calculator. So 0.9082 minus 0.7486. Okay, 0.1596. All right, there we go. There's our answer.